All right, so let's talk about the questions on the checkpoint for Module 2, all of which are kind of talking about this same graph here. But first question, global mean temperature was changing most rapidly in 2005. How quickly was the temperature changing in 2005? So first, let's get a sense of what this graph means. So graph below shows the global mean temperature in degrees Celsius between 2000 and 2009. So it looks like T equals 0 represents 2000, and T equals 9 represents 2009, so T equals 5 should be 2005. So how quickly was the temperature changing in 2005? So we've talked about rates of change, but more specifically, we've talked about constant rates, instantaneous rates, average rates. I think the biggest hint here that we are looking for an instantaneous rate of change comes from the fact that you are being asked about what's happening in 2005, as opposed to, they're not asking what's happening, how's the temperature changing in 2005, not, for example, how was the temperature changing between 2003 and 2007. We are given one point in time and not an interval, like not some wider uh, separation in time. So we're looking for an instantaneous rate of change. So now that we've talked about what kind of rate we're looking for, we can talk about how to find an instantaneous rate of change. And graphically, an instantaneous rate of change is probably going to be most directly gotten through the slope of a tangent line. So let's find the slope of a tangent line. So we care about what's happening at t equals 5. So I'm going to draw some vertical hash marks through here. So we have a lot of lines going on. We have a steep line that cuts through C. It's a negative slope. I don't believe that's going to give us what we want because that doesn't appear to be a tangent line. What about the other two lines? So what about this line here? I believe that line most closely resembles a tangent line. So if we can pick a couple of points off that tangent line and find a slope there, we should be able to get the instantaneous rate of change. So one thing I'll remind you of now is there were multiple choices to this, and I did not copy them down, but whatever answer we get should be very close to one of those. So let's pick some points that are very far away from each other. That'll give us the best chance of, estimating our slope here. So I'm going to choose these 2 points. I'll call this point A, point B. So how do we find slope? The same way you have for probably years now. I want to find f of B minus f of, minus f of A divided by, let's not liking the representation I'm using there. Let's do the y value at B minus the y value at A over the x value of B minus the x value at A. So let's find the coordinates of these points. This looks like 8.5 comma 14.3. And what's happening at A? This coordinate looks like x equals 2, y equals 14.9. So from those values, I should be able to find the slope. So the y value at B is 14.3 minus the y value of A, which is 14.9, over the x value of B, which is 8.5, minus 2. So this gives me negative 0.6 over 6.5. And let's get an approximation for this. Should be negative 0.092. And what are the units that go with this? So when you're looking for the units of a rate of change, it's really going to come from whatever the units are of the quantities that are covariating. So what's our y variable? On our y-axis, that's measured in degrees Celsius. And what's our horizontal axis? What's our x-axis measured in? Those are measured in years. So instantaneous rate of change here is about negative 0.092 degrees Celsius per year. So let's get and move on to question 2. What are the output units for the answer to the previous question? So got a little bit ahead of myself. So back to the slide here. Yeah, so for the reasons we just talked about, our output unit should be degrees Celsius per year. Moving on to question 3, which of the following is false? So let's go through each one. The instantaneous rate of change is greatest at B. So let's look at B. You're talking about instantaneous rate of change, and we're looking at a graph. So if at all possible, let's try to estimate the rate of change at the instantaneous rate of change at B by drawing a tangent line. It looks like B, because it has it comes to like a peak there. I would call this a horizontal tangent line. And if it's a horizontal tangent line, then what can I say about the slope there? I believe that slope is going to be 0. That seems like it's going to be false, but let's look at the other options to be sure. The tangent line lies below the curve at point D. So I don't see a tangent line at point D, but let's try to draw it. It should look something like this. That seems true to me. It seems like the tangent line is going to exist below the curve. So I'm going to eliminate this option. The derivative at point B is greater than the derivative at point C. So we already said the derivative at point B. And remember, instantaneous rate of change and derivative, these are, in this context, those are absolutely the same. We'll talk more about when the word derivative is not specific enough, but in this case, the instantaneous rate of change is the derivative. We already said the derivative at point B is 0. So what can we say about the derivative at point C? So at point C, what's happening? Let's try to draw a slope of a tangent line again. So that's going to look something like this. So if you read that line from left to right, we are seeing that it slopes downward. That tells me that this derivative is negative. It's less than 0. So because of that, I think the derivative at point B is greater than the derivative at point C. So I'm going to eliminate that choice. And finally, the slope of the tangent line is positive at point A. So let's look at point A. If I were to draw a tangent line, I believe that would be positive. So I'm going to eliminate that choice. So it looks like the first option is correct. So the instantaneous rate of change is greatest at B. Another way we can know that that's not true is anywhere on this graph where the instantaneous rate of change is positive. So A and D are good choices for that. The instantaneous rate of change in A and D is going to be greater than B. So B cannot be the maximum. B cannot have the maximum derivative. So moving on to question 4. What does the slope of a line that passes through the points A and C represent? So before we get to that, let's draw that line. So it passes the straight line that passes through A and C. So I want to highlight my answer to this question by talking about how we talked about part A. I said part A talked about an instantaneous rate of change because it asked what was happening at a single point in time in a single year. So contrast that with what's happening here. I am asking about what's happening at and between 2 different points. So think that tells me right away that we are looking at an average rate of change. So that's not specific enough to answer this question, but it is very valuable to know that we're not looking at an instantaneous rate of change. We're looking at an average rate of change because I'm talking about point A and point C. So what exactly is the average rate of change I'm looking at? So what does the slope of this line tell me? So maybe it'd be helpful to talk about how to calculate that slope. So how do you calculate any slope? It's a change in output values. So the y value of point C minus the y value of point A divided by this difference, the x value at point C minus the x value at point A. So what are these things measured in? We've already kind of talked about that. This is going to be a change in degrees Celsius per year. So let's now put all these things together. This should be the average rate of change in what? Global mean temperature, because that's exactly what this graph tells about. In global mean temperature. And if I'm talking about an average rate of change, I really need to be talking about the span of time it talks about. So the average rate of change in global mean temperature between T equals 1 and T equals 5. So what years does that correspond to? I think we said before that time equals 0 represents the year 2000. So what does time equals 1 represent? So between the years 2001 or 20,001, let's try that again, 2001 and 2005. So I think that's the most complete way to say what the slope of that line represents.